solve the system of equations. So here we have two equations, 3x squared plus 2y squared equals 35, and 4x squared plus 3y squared equals 48. Now you could solve this either with substitution or addition, and in this case it's a little bit easier to do addition because to solve for y, say in this case, you'd have plus or minus and then it'd be kind of dicey. So instead, we can just eliminate a variable, and you can either eliminate x or y, but in this case I chose to eliminate y. So I want to create something where I have y squared and a negative y squared that are equal, so they'll cancel out. And so I multiplied the first equation by negative 3, so it becomes negative 6y. And then you multiply, of course, everything by that, so it'll be negative 9x squared, and then 35 times negative 3 is 105, or negative 105. And the second equation I multiplied by 2, so I get positive 6y squared, and I'll also get 8x squared and 96. So now I can add both these equations together to eliminate the y variable. You see it cancels out, and I'm left with negative x squared is equal to negative 9, which means that if I solve for x, I get x squared equals 9, and x is equal to plus or minus 3. So in other words, there's two x coordinates that are possible, and that's 3 and negative 3. So first, let's take a look at 3. To find the y coordinate that corresponds with 3, we plug it back into any one of the original equations. I chose equation 1. I plugged it back in for x, and now I'm going to be solving for y. So 3 squared is 9, times 3 is 27. Subtract 27 from both sides, I get 8 on the right. Divide by 2, I get 4, and take the square root, I get plus or minus 2. And so what this means is there are two solutions in this case. When x is 3, y can either be 2 or negative 2. So you can see here, I have the coordinates. And when x is 3, it could be negative 2, and also 3, positive 2. And there's also the other case, when x is negative 3, we plug it back into the original equation, and similarly, we solve for y, and it's actually very similar because negative 3 squared and 3 squared are the same. So subtract 27 from both sides, I get 8 on the right, divide both sides by 2, I get y squared equals 4, and y is equal to plus or minus 2. So what this means is that if I plug in negative 3, I'm going to get two y values, 2 and negative 2, and so these 2 points are solutions to this equation, system of equations, negative 3, negative 2, and negative 3, 2. And here, so these are your 4 solutions for the system, and here's kind of a graphical look as to what it looks like. I graphed it, and you can see it looks like an ellipse, sort of, and you can see how where they intersect on a graph, that's the solution. And you can see at this point, negative 3, 2, a negative 3, negative 2, a 3, negative 2, and at 3, 2, the two graphs and the two equations intersect. And so those are our 4 solutions.